Welcome to project-based learning activity conducted by Zeal College of Engineering and Research, Pune. We are selected two components from our daily life. We are going to see material used in it, properties of the material, and the technologies which are used for the manufacturing of the component. See the first component, that is pressure cooker. Material used in pressure cooker is stainless steel or aluminum alloy. Let's learn about the properties of the aluminum alloy and stainless steel. Now let's see the manufacturing process used in pressure cooker.
A pressure cooker starts with a stainless steel disc. A dip of some lubricant will aid the forming process as equipment pushes the disc over a pot-shaped die. That flat disc is now a nicely rounded pot. Next, this punch cutter moves in to make notches in the pot's rim. These notches will interlock with the pressure cooker lid, allowing it to hold up tight against steam pressure. Next, they submerge aluminum discs in a liquid mix of aluminum and silicon to give them an even coating. While the disc is still damp, they arrange it on the bottom of the pot, then set a stainless steel disc on top of it. A turntable delivers the pot to an element that's heated to more than 1100 degrees Fahrenheit. This intense heat activates the aluminum and silicon solution to fuse the disc to the bottom of the pot. Then it's into a cooling tank where the pots flow towards the next station. There, two blades shave away the ragged edges of the fused layers on the bottom of the pot. It creates a cosmetic beveled effect. That layer of aluminum sandwiched between the steel will improve the pot's heat conductivity. And now it's time for some grit and polish. In this special chamber, sanding and buffing tools add luster to the pots. The pressure cooker pot then takes a trip through a washing station to clean off the sanding residue. And now it's ready for the crowning touch, the lid. It takes 6 pressing operations to shape it completely. The holes at the center are for the pressure cooker's 2 safety valves. To install the main valve, they align a retaining ring with the lid's larger hole, then pop the spring valve into that hole. An automated device underneath tightly screws it into place. The backup valve goes in the smaller hole. These 2 valves are crucial. They'll release excess steam to avert an explosion. A rubber ring creates an airtight seal with the pot. They test the valves and check the sealing ring, along with the lid's closing mechanism. This plastic cooking guide encircles the main safety valve, but doesn't impede its function. They weld several bolts into the pot on either side. They leave a bit of space between the bolt heads and the pot. This allows them to install the brackets for the handles. They torque the bolts to tightly secure the bracketed handles. After all, a pressure cooker is one thing you don't want to lose your grip on. And now this pressure cooker is in the home stretch. There's one last test, which they perform on randomly selected pots. They pump the pot full of air to simulate the effect of steam and confirm that this pot can handle the pressure. Pressure cookers with double walls are another innovation. They'll keep that stew warm longer to ease the pressure on the chef.
Selected, that is ceiling fan. The materials used in ceiling fan is aluminum alloy. Let's see about the properties of aluminum alloy and the construction and the working of ceiling fan. Now let's see the manufacturing process used in ceiling fan.
The ceiling fans include 2 major components, that is, the motor and the blades. Long aluminum sheets are cut into appropriately sized fan blades. Then the corners of these blades are shaped and the holes are drilled for fixing the rivet. Now the edges of the blades are smoothened. Later, these blades are angled to improve the airflow. Blade pitch is the angle of the ceiling fan blades. Hence, the greater the angle, the higher the scoop of air the blades can push. Then the aluminium blades are fitted with the angled mild steel shanks with the help of rivets. These are manually hammered. Then, these blades are given to special purpose electrical machines where rivets are pressed. Thus, the shank and the blades are fixed permanently. These are then sent to paint according to the specified colors to match the decor of the home. For the stator, the slot insulation papers are first filled into the main winding slots. And then, the copper wire is wound over these, which is called the main winding. Further, they are sent for popping in the insulation to the starter winding slots. Then, the copper wire is wound over the insulation. These stators are varnished and dried by heating or baking. These dry stators are then fitted with the shaft by hydraulic press. The stator outer diameter is then grinded. This is to make the air gap between the stator and the rotor even all over, which avoids magnetic losses and humming noises. The top-bottom covers are sprayed with paint and dried. The painted top-bottom covers are fitted with the ball bearings. The stators and rotors are fixed together onto the top-bottom covers and manually tightened. Now the capacitor is fitted along the shaft with rivets. Once the capacitor is fixed, the stator winding and the capacitor wires are split into positive and negative terminals. Then these segregated wires are fitted in the slits. Then, slim lines of gold coating is painted along the circumference of the motor. Based on the noise level and other factors, the motors that pass the test are finally sent for packing. The tested motors are then cleaned and packed along with the packets of screws, down rod, and canopy. These major components of the ceiling fan are packed into cartons and exported.
From Zeal College of Engineering and Research, Pune. Our group members are Kompalwar Kiran, Rohit Kumbar, Omkar Malji, Kanakraj Mohite, and Sandesh Mohite. We are done this project under the guidance of Professor Gujar SH. Thanks to Zeal College of Engineering and Research, Pune, to giving this opportunity to us.